Hello guys, welcome to Kodamigo. In this video, we're going to talk about interfaces in Typescript. If you are someone who is coming from object-oriented programming language such as C#, C++ or Java, then you must have some idea about this. First, we will understand what interfaces are and how can we ensure that the objects that we are dealing with are going to have at least certain properties so that we are 100% sure when you are accessing them or looping over them. And next we will talk about how we can specify signatures of functions, and then we will see if there are many interfaces, how can we extend existing interfaces into the new one. The one particular use case of using interfaces with classes, classes and interfaces, they go hand in hand. So oftentimes we have classes being implemented interfaces to make sure that they have certain properties and methods in them. So we will also have a look at this. Last but not least, we will see how can we create generic interfaces in this video. We're going to learn pretty much everything that you have to know about interfaces. Now let me quickly jump over to my IDE. I'm using Visual Studio Code. So let me have a method. The name of the method is print, which is accepting parameter, and I'm calling it planet data. I have some if else conditions here. If the habitable property is available, then I'm just printing the tilt angle of the planet. Otherwise, I am multiplying the tilt angle with the golden ratio, and then I'm printing it. So here's the one instance of spin method. So I am saying that the name of the planet is Neptune, tilt angle is this and this. And let me have one more similar statement. In this case, the name of the planet is Earth and it is habitable. So there's nothing wrong with this code. If I go ahead and open up the terminal, you would see that we actually got the expected output, but there are a number of problems with this approach. The very first problem is that we are repeating these two objects, and it is very easy to misspell any one of the property, or somehow forget the property, or somehow end up giving the property some wrong values. In such case, Typescript is not helping us out because we have specified that planet data could be anything. In this case, like, our program is not going to work as expected, because in this case the tilt property does not exist and is habitable is missing on the Earth object. So let me save this and try to run this program. You got the idea. It might run, but we got unexpected out. It gave me NaN when we passed in Earth data, and this is so happening because of this if else condition. So is habitable is undefined for Earth, the else case will be executed, and tilt angle is also not available. So this whole expression is undefined. So we are multiplying some number with undefined, which is not a number. So now let's go ahead and instead of saying any, let's say that I am expecting an object. Now as you can see that what I have done is, instead of using any as the type of this variable, I have specified that I'm expecting an object, and that object going to have these three properties: name, tilt angle, and is habitable, and the type. So even if I'm passing in is habitable, it's saying that it is not of a string, it is of boolean. So let me fix this first. Next up, it's saying that that tilt angle is not assignable. So let me also fix this just like before. Now I'm running this program with all the required properties: name, tilt angle, and is habitable, and now Typescript is happy. I can run this program. We're going to get the exact same output. This approach is kind of working, but there's a flaw or drawback of this problem. What if we have to supply the planet data elsewhere? Let's say there are 5 or 10 such calls to this method, or maybe not calls. Let's say we are not using a spin method, like there's another method that requires the same shape of the object. Then we will end up repeating ourselves. So in order to solve this problem, we can simply go ahead and create an interface. So let's go ahead and quickly define an interface. For this, we have an interface keyword, and then we have to specify the name of the interface we're going to provide, and then the definition of the interface. The one last thing, we have to use this interface. So now I'm saying that this variable, this argument, going to be of this type. If I hover on it, if I, let's say, remove some properties, I'm going to get the exact same thing, but I will not have to repeat myself if I have to create more objects which are supposed to have these three properties. So for instance, instead of passing this whole object, I can create a variable. Let me create a constant. Let's call it Neptune. The type of this constant going to be of type heavy bodies. And here I have specified the object, and I can simply pass in the Neptune. This will work. So I am just using the interface we have created, which means that I'm not repeating myself. And I'm making sure that the parameter that a spin method is accepting is of this shape. So this is guaranteed, at least at compile time, because runtime interfaces don't exist. If you open up a compiled version of this file.js file, you would not see interface anywhere. So it's a zero cost. There's no boilerplate code to create interfaces, because interfaces don't exist in JavaScript. In object-oriented programming languages, the primary use of interface is to define a contract, and which means that any class that choose to implement an interface has to have certain properties and methods. So let's see how we can do the same in Typescript. Let's say I have the same interface, heavy body, which has three properties in it, and this time around I'm going to say that there's going to be a method called spin. This method is not accepting any parameter, but it is returning a number. So there are in total 4 properties now. Let's go ahead and define a class. Let's call this planet. The class planet is implementing heavy body. So we have implement keyword. If there are more than one interface that one class wants to implement, you need to provide the comma separated list. So you can do this. Now let's define some properties of the class, because since the planet class is implementing heavy body, it must have name, tilt, angle, is habitable, the spin method. Let me go ahead and define the constructor. Let me assign the properties to it. And now there's one more error. It's saying that property spin is missing. Okay, let's go ahead and define the method. So we have the method now, and this method is supposed to return an integer. If I hover on it, the name of the class is planet, which is a method. Spin is a method. It is accepting no argument but returning a number. Typescript knows this implicitly since we have specified it here, and also it is returning a number. So let's go ahead and create an object of this class. So since this planet class is now accepting 3 arguments, we are providing all of them. If I, let's say, miss any one of the type, we would not be able to call the constructor. So make sure that we have all the arguments needed. Let me console out the output. Go ahead and open up the terminal. Hopefully we're going to get the same out. Here you say the constructor is saying that creating planet, and then it has printed out all the details. This one is coming from the spin method. So this is how we enforce that this class going to have this many properties and one method. You see that we are having to declare first our class variables, class instance variables, and here we are assigning them the values. So to make it a little bit short, let me apply a shortcut. We do not need these declarations, so let me remove them. Also, we don't require these 3 things. Instead, what we can do is that I just need to type the public keyword, and this public keyword is everywhere just before these 3 properties. So this, having this public keyword, is same as doing this dot name is equal to name. So now our code is a little bit cleaner. Okay, let's move on. Let me quickly define one more interface. Let's call this body type, and this is going to have just one property called body type, which is of this type. So let me define a type quickly here. So this is a union type. The value of body type property could be any one of these 2. Now let's go ahead and extend the I body type into heavy bodies. That means if I do this, we have extends keyword for this. If I say I for interface and body type, heavy body has all of its properties along with its method, but this time it has one more additional property, which is body type. So if I hover on it, it is saying that body type is missing, but that is required type. So now we will have to specify body type here. Now I have provided the body type. There is no error in the class, but there is an error at the down here. So let's quickly fix this. So in this case, what I have done, I have extended the heavy body interface with I body type. Or there's one more way of doing this. Instead of using extends keyword, I also can say that this planet class is going to implement 2 interfaces instead of just one, which is same as extending the body type, the I body type interface into heavy body and then implementing just one interface. Now the planet class has implemented 2 interfaces, and it is also satisfying all the properties, the method that interfaces have. So just to see the output and just to check if this program is working, let me go ahead, open up the terminal and run the command. Yeah, it is still working. So we have body type, which is rock by default, and everything is working just like before. Now we are left with just one point, that is how to make some generic interfaces, right? For this, let me go ahead and create another type, and let's call this more body type. So here I'm basically combining the body type plus I'm adding one more property to this. It's going water. So here we are kind of hard coding the body type, meaning that the I body type can be of this type, but we want to turn it into a generic interface. So we have to specify the type that is unknown out of the time, and let's call this T. We have to follow this structure or this syntax. Instead of saying body type, I'm saying it is of type. Now if you see that down here at bottom, it's saying that it requires one argument because it is generic type. So let's say I body type going to be of more body type. So now we have to specify the type of the interface, and it is working just as before, but since we have added one more option, the I body type is of more body type, so we can pass water as well. Let me type in water, and let me also change this body type to be more body type. Okay, now it is no longer complaining. So let me save this, go ahead and run the program just like before. And this time you see that the body type is water. So we had to change the type of body type from body type to more body type, We can also make this generic, but that's not the topic for today. We can have generic classes as well. Let me quickly have one more example of this. Let me define a class called moons, and this moons class, very much like planet class, is going to implement heavy bodies. Now we have to implement and provide the properties and methods that this interface has. But just like planet, I'm going to implement one more interface, and it is body type. But earlier we used more body type because we had to create a very special planet called Earth, which is a water planet. But since we're creating moons, and I think no moon has water, so in this case we can say that body type is of type body type, meaning we can pass in these two possible values, rock and gas. To satisfy the class, let me create constructor and the final spin method as well. So in this case, you see that body type is generic. At one instance, I'm passing body type as the type of body type, and here at line number 25, I passing in a different type. This is how we can create generic interfaces in TypeScript. Yeah.